change of sign. This idea is very, very useful, and it's such a simple idea. You see, something can only change sign, go from positive to negative. You can only change it in two situations. At the x-intercepts, you can't go from positive to negative without passing through zero. It's like when you're driving a car. You can't go forwards and then backwards without stopping. Might be for an instant, but at some point you must stop. Same idea. But the other one with a function, of course, is the discontinuity, like our hyperbola. It went from negative to positive because there was a discontinuity at x equals 0. So it was able to do that. So they're the two situations. This brings back the idea of critical points. You can always find the critical points of an equation by moving all the terms to one side. Now why do that? Because that now means you're talking about something that equals or is greater than equal 0. Then you find that function. Something like this. Here it is, everything's been moved to one side, I've factorized it, and we're saying, hey, this is always going to be negative. If I was to draw the picture, I could do x minus 1 squared times x plus 3. We know we've got a graph that looks like that. We've got a double root at 1, so it just touches and it cuts through at -3, and we think about it and say, well, when is this curve below the x-axis? Well, okay, there's the 2 points. When is it below the x-axis? Well, there. Interestingly, in an equation like this, people often forget x equals 1 for some reason. That's a singular point, but it is a solution to the equation. So there it is as a picture. But basically it's finding those x-intercepts. X-intercepts, that's when it's changing the sign. We come back to this inequality that we saw before. We could do it this way. Let's move everything to one side. It creates this algebraic fraction. It becomes minus 13 minus 5x on x plus 3. When is that negative? Well, we know it's only going to change sign in one of two situations. When it's an x-intercept or when it's an asymptote. Well, that's the top of the fraction and the bottom of the fraction, isn't it? X-intercepts must be when the top of the fraction is equal to 0. Discontinuity must be when the bottom of the fraction is equal to 0. So our critical points will be the zeros, the top of the fraction, minus 13 on 5. The discontinuities will be the bottom of the fraction, x is -3. There's your two critical points. Test your regions and you get your answer. It's the same idea, but pulling everything to one side first. Okay, there we go.